Welcome back to Alien Professor. Today we are talking about something that is making cosmologists question everything: ancient supermassive black holes found by the James Webb Space Telescope. Black holes so old and so massive they should not exist, according to our current understanding of the universe.
So your fancy new telescope broke your favorite theory. Classic humans. Build better tools. Ruin your own worldview.
Not exactly broke, but definitely challenged. We will look at what James Webb actually found, why these black holes are so surprising, and whether the Big Bang Theory is really in trouble, or if we just need to adjust some details.
So, ancient cosmic monsters, confused scientists, and possibly rewriting textbooks. Sounds like a regular Tuesday in astrophysics.
Pretty much. Let us start with what we thought we knew: the Big Bang and black hole formation.
Explain it like I just arrived from a dimension where time runs backwards, and your physics makes no sense.
The Big Bang happened about 13.8 billion years ago. In the first moments, the universe was incredibly hot and dense, filled with fundamental particles. As it expanded and cooled, these particles combined to form hydrogen and helium, the first elements. For hundreds of millions of years, the universe was dark. No stars, no galaxies, just clouds of gas slowly gathering under gravity. Then, around 100 to 200 million years after the Big Bang, the first stars ignited. These were massive, short lived stars called population 3 stars. When they died in supernovas, they left behind small black holes, maybe 10 to 100 times the mass of our sun.
So, baby black holes. Cute. Let me guess, they were supposed to slowly grow up by eating gas and merging with each other over billions of years.
Exactly. According to traditional models, supermassive black holes, the ones weighing millions or billions of solar masses, formed gradually. Small black holes merge, attract gas, grow bigger, merge again. This process takes time, a lot of time. We estimated it would take at least several hundred million years, maybe a billion, to build up the supermassive black holes we see in the centers of mature galaxies today.
And then James Webb looked really far away, which is the same as looking really far back in time, and said, "Surprise! Giant black holes everywhere. Way too early."
That is essentially what happened. In late 2024 and early 2025, multiple teams reported findings. One particularly shocking discovery was a galaxy called CANUCS LRD Z8.6. This galaxy exists just 570 million years after the Big Bang. That is less than 5% of the current age of the universe, and it hosts a supermassive black hole that is actively growing extremely rapidly.
Ha ha ha! 570 million years. That is like finding a teenager with a PhD and a mortgage. It should not be possible yet.
Great analogy. The lead researcher, Roberta Tripodi from the University of Ljubljana and INAF in Italy, said this discovery is truly remarkable and challenges our understanding of black hole and galaxy formation in the early universe. What makes it even more compelling is that the black hole is overmassive compared to the galaxy's stellar mass. Normally, there is a relationship between the mass of a galaxy's stars and its central black hole. Here, the black hole is disproportionately huge.
So, the black hole is the main character, and the galaxy is just a supporting actor, the cosmic equivalent of the tail wagging the dog.
That is one way to put it. And CANUS is not alone. James Webb has found multiple supermassive black holes in galaxies from the first billion years of the universe. Some are as heavy as 50 million solar masses or more. One discovery, called QSO-1, appears to be a naked black hole, meaning astronomers cannot even clearly identify a surrounding galaxy. It is just a massive black hole sitting there in the early universe, seemingly by itself.
A naked black hole, no galaxy clothes, just vibing in space at the dawn of time. That is either terrifying or hilarious. I cannot decide.
It is definitely puzzling. The traditional bottom-up model, where stars form first, collapse into small black holes, and those gradually merge and grow, simply does not have enough time to produce these monsters. If you do the math, starting from a stellar mass black hole of, say, 100 solar masses, and assuming continuous gas accretion at the maximum theoretical rate, the so-called Eddington limit, you still cannot grow it to millions of solar masses in just a few 100 million years.
So, either your math is wrong, your theory is wrong, or these black holes cheated. Maybe they used a cosmic cheat code. Up, up, down, down, left, right, BA start.
Or, more likely, we are missing a formation pathway. This is where the concept of heavy seeds comes in. Instead of starting with small stellar remnant black holes, light seeds, perhaps some black holes in the early universe, formed directly from collapsing gas clouds without ever being stars first. These are called direct collapse black holes, and they could start out much heavier, maybe 10,000 to 100,000 solar masses right from the beginning.
Wait, so instead of star dies, becomes black hole eats and grows, you are saying. Gas cloud just gives up and becomes black hole immediately, skipping the whole star step.
Exactly. Under very specific conditions, if a gas cloud is massive enough, hot enough, and lacks the elements that would normally allow it to cool and fragment into stars, it can collapse directly into a black hole. This would give you a head start. You begin with a much more massive seed, and then even moderate growth over a few 100 million years could get you to supermassive sizes.
So, these black holes are the cosmic equivalent of trust fund babies. Born rich, did not have to work their way up from a minimum wage star job.
That is actually a pretty good comparison. Recently, NASA reported that James Webb may have found evidence of exactly this process. An emerging galaxy system that researchers nicknamed the Infinity Galaxy due to its infinity-shaped structure from two colliding disk galaxies. A supermassive black hole sits in the middle of a vast gas expanse, not neatly inside either nucleus. The team, led by researchers including those from the University of Ljubljana, proposed that this black hole formed via direct collapse from that gas.
So they caught one in the act, like finding a Pokemon mid-evolution.
In a sense, yes. They measured the velocity of the gas and the velocity of the black hole, and found them to be almost identical, within about 30 miles per second. If the black hole had formed elsewhere and was just passing through, or if it was in an unrelated galaxy, the velocities would not match. This strongly suggests the black hole formed directly from that gas cloud.
Okay, so direct collapse black holes solve the timeline problem. Case closed. Big Bang Theory saved. Everyone goes home happy.
Not so fast. Direct collapse helps, but it requires very specific conditions. You need a gas cloud that is metal poor, meaning very few heavy elements, because metals help gas cool and fragment into stars. You also need intense ultraviolet radiation from nearby sources to keep the gas hot and prevent star formation. These conditions might have been more common in the very early universe, but we are still working out exactly how often they occurred. Some models suggest direct collapse could only happen in rare pockets of the early cosmos, perhaps accounting for just 1 to 10% of supermassive black holes, with others forming via light seeds or mergers.
So, it's a possible explanation, but you are not 100% sure it happened enough times to explain all these overgrown black holes.
Correct. There is also another idea. Priya Natarajan from Yale and Tal Alexander from the Weizmann Institute proposed a runaway collapse scenario. In an exceptionally dense star-forming region, one star collapses into a large black hole early on. Then that black hole zooms around like, as one article put it, Pac-Man, devouring gas and growing rapidly. Meanwhile, the other massive stars in that region live fast and die young, winking out quickly. You are left with a giant black hole and not much else.
Cosmic Pac-Man. Haha, I love it. Waka waka waka, eating stars and ruining your timeline predictions.
The key point is that we now have multiple competing hypotheses. Light seeds with super Eddington accretion, meaning black holes eating faster than we thought possible. Heavy seeds from direct collapse. Runaway mergers in dense environments, possibly some combination of all three. James Webb is giving us the data to test these ideas, but we do not have a single clear answer yet.
So, when humans say James Webb challenges the Big Bang Theory, what they really mean is it challenges the specific timeline and formation models you built on top of the Big Bang Theory. The Big Bang itself is fine. You just got some details wrong about what happened in the first billion years.
That is a very accurate way to put it. The Big Bang framework, the idea that the universe began in a hot, dense state and has been expanding and cooling ever since, is not in question. The evidence for that is overwhelming. Cosmic microwave background radiation, the abundance of light elements, the large-scale structure of the universe, redshift of distant galaxies, all of that still fits.
So, the foundation is solid. You just need to redecorate the first floor.
Exactly. What James Webb is challenging is our understanding of structure formation in the early universe. How quickly did the first stars and galaxies form? How did supermassive black holes grow so fast? What were the conditions like in those first few 100 million years? These are important questions, but they are refinements, not a dismantling of cosmology.
Okay, but be honest. How many scientists are secretly panicking, like late at night, staring at the data, whispering, what if we got it all wrong?
There is definitely excitement and some healthy discomfort. When your observations do not match your models, that is when science gets interesting. But panic is too strong a word. Most researchers see this as an opportunity. We built models based on limited data from older, less powerful telescopes. Now we have James Webb, which can see farther, in more detail, with better spectroscopy than anything before. Of course, we are finding surprises. That is exactly why we built it.
So it is less. Oh no, everything is wrong. And more. Oh cool, we get to figure out new stuff.
Precisely. In fact, this is how progress works. You make a model based on available data. You build better instruments. You find things that do not quite fit. You revise the model. Repeat. The Big Bang Theory itself went through this. It was proposed in the 1920s, refined in the 1940s and 50s, got major boosts from the discovery of the cosmic microwave background in the 1960s, and has been continuously updated as new data came in.
So, what you are saying is, the Big Bang Theory is not some fragile house of cards that collapses when you find one weird black hole. It is more like a giant Lego structure that you keep adding pieces to and occasionally rearranging.
That is a great metaphor. The core structure is extremely robust. The details at the edges are always being refined. Right now, the edges we are refining involve the formation of the earliest massive structures.
Let us talk about the telescope itself for a second. Why is James Webb finding all this stuff that Hubble missed? Is it just bigger? Or is there some magic space trick happening?
It is not magic, but the engineering is remarkable. James Webb observes primarily in the infrared, while Hubble focused more on visible and ultraviolet light. When light from very distant galaxies travels across the expanding universe for billions of years, it gets stretched by that expansion. This is called redshift. Light that was emitted as visible or ultraviolet gets shifted into the infrared by the time it reaches us. So Webb is specifically designed to see the earliest, most distant, most red-shifted objects.
So, Hubble was looking with the wrong kind of eyes, like trying to see infrared with regular human eyeballs.
Exactly. Webb also has a much larger mirror, 6.5 meters compared to Hubble's 2.4 meters. Bigger mirror means more light collected, which means fainter, more distant objects become visible. And Webb's instruments can do spectroscopy, breaking light into its component wavelengths with incredible precision. That lets us measure not just how bright something is, but exactly what elements are present, how fast it is moving, and how far away it is.
So, it is like upgrading from a flip phone camera to a Hollywood film camera. Suddenly, you see details you didn't even know you were missing.
Perfect analogy. And that is why discoveries are coming in fast. Webb has only been operating since mid 2022. We are still in the early days of analyzing the data. There will be more surprises.
All right, here is the part where I get philosophical. If these black holes formed so early, and some of them are just sitting there naked without galaxies, does that mean black holes came before galaxies? Like, did black holes create galaxies instead of the other way around?
That is one of the big questions now. The traditional view was galaxies first, black holes second. But some of these discoveries suggest the opposite might be true, at least in some cases. There is a theory that massive black holes could actually help trigger galaxy formation. A big black hole pulls in gas. Some of that gas gets heated and blasted outward in powerful jets and winds. That can compress surrounding gas clouds, triggering bursts of star formation. So the black hole seeds the galaxy around it.
So, instead of the galaxy being the parent and the black hole being the baby, sometimes the black hole is the parent and the galaxy is the baby. Cosmic role reversal.
Essentially, yes. This would flip our picture of cosmic evolution. It also connects to the observation that almost every large galaxy today has a supermassive black hole at its center, and the mass of that black hole correlates with the mass of the galaxy's central bulge. We have always assumed galaxies and black holes co-evolve, growing together. But maybe in the very early universe, black holes got a head start and shaped the galaxies that formed around them.
That is wild. So these ancient black holes are not just challenging your timeline, they are challenging the whole cosmic family tree. Who came first? Who raised who? All of it.
Exactly. And this is why the James Webb findings are so important. They are not just adding data points. They are forcing us to reconsider fundamental assumptions about how structure formed in the early universe.
Okay, devil's advocate time. What if all of this is just measurement error? What if these black holes are not actually as massive or as old as you think? What if Webb is just confused?
That is a fair question, and scientists are absolutely checking for that. The measurements rely on spectroscopy, analyzing the light to determine redshift, which tells us distance and age, and also the motion and emission of gas, which tells us the black hole mass. These techniques are well established and have been cross-checked with multiple methods. In the case of CANUCS LRD Z8.6, the team used Webb's NIR spec instrument to get detailed spectra. They confirmed the redshift, measured the gas velocity, estimated the stellar mass of the galaxy, and compared it to the black hole mass. Multiple independent lines of evidence point to the same conclusion.
So, it is not just one number that looks weird, it is a whole bunch of measurements that all agree these black holes are ridiculously massive and ridiculously old.
Correct. And these results are peer-reviewed. Other scientists examine the methods, check the data, and try to find alternative explanations. So far, the findings are holding up. That does not mean they are immune to revision, but the evidence is strong.
What about the people on the internet saying this disproves the Big Bang? Are they just clickbait merchants? Or is there any serious scientific debate about throwing out the whole theory?
Mostly clickbait. In the scientific community, there is no serious movement to abandon the Big Bang framework. What you do see is debate about specific models of early structure formation, the role of dark matter, the exact timeline of reionization, the efficiency of black hole growth. Those are active areas of research. But the core Big Bang cosmology, supported by decades of observations, is not in doubt.
So when you see a headline like, James Webb destroys the Big Bang, the accurate version would be, James Webb finds interesting data that requires updates to models of early black hole formation within the well-established Big Bang framework. But that does not get clicks.
Exactly. Nuance does not make good headlines, but it is the reality of how science works. We're not tearing down the house, we're renovating the attic.
All right. Predictions. 10 years from now, what will we know about these ancient black holes that we do not know today?
I think we will have a much clearer picture of how common direct collapse black holes were in the early universe. We will probably identify multiple formation pathways and understand which dominated under which conditions. We will have better simulations that can model the complex interplay of gas dynamics, star formation, black hole growth, and feedback processes in the first billion years. And honestly, James Webb will probably find even weirder things that raise new questions we have not thought of yet.
So, the answer is, we will know more, but we will also have more questions. The eternal scientist's curse.
That is the nature of the job. Every answer opens three new questions.
Last question. Why should regular humans care about ancient black holes? Like, what is the practical impact of knowing whether a black hole formed in 500 million years or a billion years?
On a practical day to day level, it does not change much. You will not wake up tomorrow and find your coffee tastes different because we revised early black hole models. But on a deeper level, this is about understanding our cosmic origins. How did the universe go from a hot soup of particles to the rich tapestry of galaxies, stars, planets, and life? Every piece of that story matters. These ancient black holes shaped the galaxies that formed around them, and those galaxies eventually produced stars like our Sun and planets like Earth. Understanding the early universe helps us understand how we got here.
So, it is the ultimate origin story. Not just where you came from, but where everything came from.
Exactly. And there is something profound about using the light from objects billions of light years away to reconstruct the history of the cosmos. We are looking back in time, watching the universe grow up. That is not just science, it is philosophy, it is history, it is art. It is humanity trying to understand its place in the universe.
That was unexpectedly poetic. I almost forgot you are a scientist.
Science and poetry are not opposites. The best science often feels like both.
So where are we? James Webb found supermassive black holes in the early universe that are way too big and way too old, according to old models. This does not destroy the Big Bang Theory, but it does force scientists to rethink how black holes formed in the first few 100 million years. Possible explanations include direct collapse, superfast accretion, and runaway mergers. And maybe, just maybe, black holes came before galaxies and helped build them, which is a total inversion of what we thought.
That is an excellent summary. The Big Bang framework is fine. Our models of early structure formation need updates, and James Webb is giving us the data to do exactly that. This is science working as intended. We built a better telescope, we found surprising things, now we figure out what they mean.
In other words, Humans built a time machine camera, pointed it at the baby universe, and discovered the babies were way more advanced than expected. Now, you have to rewrite the baby books.
I genuinely cannot improve on that analogy. That is exactly what is happening.
Want to know what is real, what is exaggerated, and what is just cosmic clickbait? Subscribe to Alien Professor. Science meets skepticism in every episode.
Hit like if you think naked black holes sound like a cosmic horror movie. Subscribe if you want to follow along as we unravel the mysteries of the early universe, one overgrown black hole at a time.
And remember, the Big Bang is not canceled. It just got a very expensive and very complicated patch update.